Hey Smita, good evening, all of you. So I hope all of you are well. And today we are starting the topic structures, right? The very important topic from inorganic chemistry. If you see your chemical bonding chapter, in that they have given in initial topics, right? So first of all, we will learn how to make structures, and then we will see its applications. Like using structure, which topics you can solve very easily, and definitely minimum 3 to 4 questions in the NEET exam depend on the structures only. Almost you can say 15 questions come from inorganic chemistry. Somehow they ask from hybridization also, and you can say bond angle, bond length, bond order. So everything, all the topics depend on structures, right? So you'll see a little bit applications, and first of all, let us start how to make structures. In NCERT, maybe you have some different ways. We will discuss some different, like, simple way how to draw structure, right? Okay. Structure and its applications. So first of all, you have to keep just 2-3 points in your mind. I will not move like step by step as given in NCERT. You have to understand like 2-3 points. If you keep in your mind, you will be able to draw structures. Not a big deal, right? Like, first of all, if you know, the first point I'm saying, there are 2 type of atoms in a molecule. Yes, good evening, Gayatri. There are 2 type of atoms in a molecule. One we call center atom, and one, which one? Surrounding. So let me be clear about it. Imagine I'm writing a structure here. Okay, it's A here, and here B. Imagine here something B, it's B, and it is also B. Maybe something else, right? So whenever I will say center atom or central atom, I am talking about A. A is present in center, so I am calling it center or central atom, right? Okay. Whereas this B beta, yes beta Yogesh, hello bacha. So these B beta, this B, if you see, these B I am calling as surrounding atom, right? So be clear about it. But when I'm calling center atom or surrounding atom, clear? Okay. Okay bacha, good. So first of all, let us discuss about the center atom, right? Center atom, basically, I'm telling you, you will see in all of your molecules, center atom will be which elements mainly I am talking about, right? So if you see, first of all, I'm writing here. Look at this. In most of the questions, you will find your center atom beryllium, or you can say bit of boron you will have, carbon you will have, nitrogen you will have, oxygen, right? And you see, what is the similarity in all of these? Can you tell me what is the similarity? What is the same thing in all of these atoms? Can you tell me, bacha? Yes, Gayatri. Okay. Beryllium, boron, carbon, nitrogen, oxygen. In many examples, you will see these will be your center atoms. Tell me what is the common thing in all of these? All of these belongs to second period in your periodic table, right? So remember, when any of these is your center atom or central element, so these can make max to max how many bonds? 4 bonds. Okay, these beta, these belongs to second period. These belongs to second period. Even I will say lithium also there, fluorine, but these will not come, right? So belong to, yes, same period. I am saying which one? Second period. So remember, these elements, maximum covalency with how much? These elements in the compounds will have maximum covalency how much? Maximum covalency of 4. Maximum covalency of 4. These can't make more than 4 bonds, right? These can't make more than 4 bonds. You can give the reason also better. What is the reason behind it? If I say reason here, why? I'm saying here, cannot make more than 4 bonds. Cannot make more than 4 bonds. Why beta? Because of absence of d over, right? In many places this will help you. Because of absence of d shell, you can say, or d orbitals you can say. Clear? चलो बच्चे, so these, remember these elements, if these are your center element, these can never make more than 4 bonds. First point. Okay, nothing tough here, right? Easy point. Now next one. Second point is, look at this, second point I'm writing here. Other than this, which elements you will see in your NCERT, in your syllabus all the time? Yes, beta. Other than this, you will see, beta, in most of times, you will see you can have mainly, you will have phosphorus many times, it will come, sulfur will come many times, right? Or beta, you can say chlorine, you will see bromine also, you will say iodine also, and if I take xenon also, right? These will be your center elements, except these. If these are not present, then these will come. Maybe some other elements are also possible, so I'm taking the most common elements, right? These belongs to third period or below it. These are not from the second period, these are belonging from third period or below it. And these have d subshells or d orbitals, so no issue. These can make many bonds. Their covalency, I'm not saying their covalency is maximum 4. They can have 5 bond also, 6 bond also, right? So can have, the main point is, can have covalency. I'm writing here, these beta, these can have covalency more than 4. You need not worry about their bonds. These can make many bonds, right? Maybe 7 bond also sometime. Okay, like in IF7, iodine making 7 bonds, right? So you don't need to worry about the bonds. These can make many bonds. Okay, I'm saying simply can make many bonds. You should not worry about number of bonds here, right? So this you have to take care about the center element, 2 points. These second period elements can't make more than 4 bonds. These other elements, mainly these will come. So these can make many bonds, can make more than 4, right? The next thing about the surrounding element. I'm talking about the third point, beta. Third point, which one? Surrounding element, right? You will see surrounding element always I am saying, in 99.9% cases, surrounding element which will come all the time? Hydrogen, otherwise halogen, otherwise which one? Oxygen. These 3 elements will be your surrounding element all the time. Here maybe hydrogen come, maybe chlorine, bromine, iodine can come, or yes Rohit, they can make more than 5 also. Rohit, these can make more than 5 also, no issue. Like in SF6, sulfur make what? 6 bonds. Okay, so more than 4, if it is there, it's no issue, don't worry about that. You will not do that mistake. Okay, if it is making more than 4, it's okay, don't worry. You should be careful about these only. Okay, now here I'm talking about surrounding element. Surrounding element will be which elements? I'm saying once again, all the time they are fixed elements. They are fixed elements. I'm saying the first one, I'm saying hydrogen. So beta, as surrounding element, hydrogen will make how many bond, beta? It will make 1 bond. It will make how many bond? 1 bond, right? yes beta, they can expand their octet, right? Now next one is, I'm talking about halogen. Halogen, beta, what it can be? It can be fluorine or chlorine or bromine or iodine. These elements as surrounding elements will make how many bond? Beta, 1 bond. Halogens as surrounding element, means corner element, outside element, will make how many bonds? 1 bond. Okay, in center, chlorine, bromine, iodine can make many bonds, but as surrounding element, it will make how many bonds? 1 bond, right? Okay, and if I talk about the next one, there is one more element, oxygen, which always come as surrounding. So means many times as surrounding, sometimes as center also, right? So if we talk about it, it makes how many bonds? It makes 2 bonds. As surrounding element, it makes what? 2 bonds. Okay, 2 bonds. Sometime, rarely, it can make 1 bond also. I will show some examples. Rarely or less, like 1 bond also possible when it is a coordinate bond. 1 bond possible sometimes. Which bond? It will be a coordinate bond, right? I will discuss about these things, don't worry. When I will take examples, you will see. So these are the 3 points we have to take care. Remaining things are very, very easy. Okay? These are some element belonging second period, can't make more than 4. If any of these come third period or below it, they can make many bonds. More than 4, like 5, 6, 7, they can make. Surrounding hydrogen as surrounding make how many bonds only? 1. Halogen as surrounding make how many bonds? 1. And oxygen in 99% cases make how many bonds? 2 bonds. Rarely, sometimes can make 1 bond also, right? As surrounding element. Are we clear about this? Tell me, bache, are we clear about this? I will start examples then. I will start examples. Tell me, are we clear up to here? Yes, bacha? Is it done? Okay, fine. So I'm taking the next case, beta. I'm taking examples. How to use this, okay? Before this, clear? Okay, clear. Before this, just tell me 1 or 2 more points. If I'm talking about the group number 1 elements, you know, lithium, sodium, potassium, rubidium, cesium. Group number 1 elements have how many valence electrons? 1 valence electron, right? Group number 2, beryllium, boron, magnesium, all these have how many valence electrons? 2 valence electrons. 13th group number, beta, boron family, right? Boron, aluminium, gallium, all of these have how many valence electrons? 3. 14th group element have 4 valence electrons. 15th group element have how many? 5 valence electrons. 16th group element have 6 valence electrons. 17th group element have 7. And 18th group elements have how many valence electrons? 8 valence electrons. Right? You know which element belong to which group? Can you tell me? You should know about it a little bit from the chapter periodicity. So I'm asking a simple question from you, because number of valence electrons you should know about the center element to start the examples, right? I'm asking simple point from you in form of question. Oh, tell me. You have tell me. Here I'm writing the element, or here I'm saying the element. Here is the element, and here I'm saying number of valence electrons. You will tell me, right? Number of valence electrons means electrons present. Number of valence electrons means electrons present in the valence shell, the outermost shell, right? Okay. You have to predict the group number. From that you can easily tell the valence electrons without even writing the configuration, right, bacha? Clear? So I'm taking the example here. Imagine I'm taking first example. I'm taking rubidium, right? Rubidium imagine. Second, these will not come in our covalent compound because it makes ionic compound all the time. Next I'm taking about beryllium. I'm taking, okay. Imagine third I'm taking aluminium. Fourth I'm taking imagine arsenic, okay. Or before that I'm writing this one, silicon, and I'm taking one more like arsenic here, and I'm taking here sulfur, beta, you can say. I'm taking bromine, right? And here I'm taking, imagine I'm talking about xenon, right? Tell me the number of valence electrons. If you see, I'm talking about the rubidium, right? Rubidium belongs to which group? Rubidium belongs to first group, right? What we have? Lithium, sodium, potassium, rubidium. So if something is belonging to first group, so we know very well directly it have beta how many valence electrons? It have 1 valence electron, right? Similarly, if I say like beryllium, second group, so I know it have 2 valence electrons. Aluminium, beta 13th group, how many valence electrons? 3. Silicon, beta which group? 14th group, how many valence electrons? 4. Arsenic belongs to 15th, so 5 valence electrons. Sulfur belongs to 16th group, beta how many? 6 valence electrons. Bromine belongs to 17th group, so 7 valence electrons. And xenon belongs to 18th group, so how many, beta? 8 valence electrons, right? I wrote in a sequence, okay, so it is easy to find. Got the point? I can take one or two examples also just to explain you. Imagine if by chance you don't remember. So I'm telling you example. I'm telling like aluminium. Aluminium beta have 13 electrons. Aluminium have 13 electrons, right? So if you write the configuration, it will come what? It will come 1s2, 2s2, what is it? 2p6 beta, what is it? 3s2 and 3p1. So its valence shell is third shell. Its valence shell is third shell, and third shell have how many electrons? 3 electrons. That's why its valence electron how many? 3 coming, right? Similarly, beta, if I talk about sulfur, sulfur is 16 electron, right? So if you count here 16, it is 1s2, 2s2, 2p6, 3s2, and I am saying here how much beta? 3s2, how much coming? 3p4. So it have how many valence electron you count? Third shell is valence shell of this, and it have how many? 6 valence electrons, because third shell have 6 electrons, outermost shell have 6 electrons, so 6 is the number of valence electrons here. Fine, okay. And one last example I am saying here, you can take the bromine, right? Bromine have 35 electrons. This will be given to you. You should know a little bit, but in the NEET exam they will give the atomic number most of times, okay. So bromine have 35 electrons because atomic number 35 here. If you write the configuration, argon 18, you can say 4s2, 3d 10. We'll have the 4s, sorry. You have 310 here. Now we have 4p beta. We have 4p, right? We have 4p here. So what's coming? 4p 5. 4p 5. So valence shell have how many electrons? 2 here, 5 here, total 7. I hope we are clear about the valence electrons, right? Clear? Because we will start the concept, or we will start the example with valence electrons only. We should know about it. Fine? Okay, bache, are we clear about this? Okay, fine. The next, we are taking some examples, the easy examples, right? I will start with easy examples only. Imagine we have a molecule CH4. We have a molecule CH4. First of all, I am not discussing that what is the structure. I am just discussing which is the central element, and it will make how many bonds with surrounding atoms, right? This is the main thing. Okay, fine. Now we know very well carbon is the center atom here. Very easy to find. Carbon belongs to 14th group. Carbon have how many valence electrons? Tell me, beta. I'm writing here 14th group element have 4 valence electrons. Carbon have 4 valence electrons, right? Good. Now after putting this central element, put these surrounding elements. Hydrogen, 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 hydrogen. Just put the central element and put in surrounding elements, right? Now I'm asking you one thing. Hydrogen as a surrounding element make how many bonds? I know it very well. Hydrogen as a surrounding elements make how many bonds? 1 bond, right? Hydrogen make 1 bond. Clear, bacha? So you see here, it will make 1 bond. Definitely it will make also 1. It makes 1. It makes 1. So every hydrogen is making 1 bond. Clear? Carbon was having 4 valence electrons, right? Carbon was having 4 valence electrons, and in making 4 bonds, carbon already used all its 4 valence electrons. Is there any electron left on carbon? Carbon was having 4 valence electrons and it used all its 4 electrons in making bonds with the hydrogen, right? So is it having any valence electron left? No, nothing is left, right? So our structure is finished. From this we get to know that carbon is making single 4 bonds with hydrogen, and now I know center atom have 4 bonds without any lone pair, right? Clear, bacha? Now similarly, if I go for the next example, I'm talking about the ammonia, right? It's ammonia. Clear, bacha? Now we know what is the center element, nitrogen. Nitrogen have how many valence electrons? Nitrogen have how many valence electrons? 5 valence electrons, right? I know this because it belongs to 15th group. It belongs to 15th group, right? So I will put here nitrogen. Nitrogen here I am showing, hydrogen I am showing like this one. Nitrogen having 5 valence electrons. Fine, bache? So hydrogen, we know that hydrogen make how many bonds? 1 bond always. So hydrogen is using and making here 1 bond, 1 bond, 1 bond, right? Nitrogen was having 5 valence electrons, and nitrogen used 3 electrons in making 3 bonds, right? I'm saying once again, nitrogen was having 5 valence electrons. Out of 5, it used 3 electrons in making bond. So how many electrons remaining? 2 electrons remaining. So those 2 electrons are or become a lone pair, right? These 2 electrons left will become a lone pair. Fine, bache? Fine? Yes, 1 lone pair will left. So it's very easy. Nothing like I'm moving step by step, I'm using any formula. No, it's very easy to draw structure, right? Okay, bacha? Now, okay, fine. Clear, bacha? Done? Okay, great. Next one. I'm not saying the structure here. Which structure it will form? What is the name of structure? It comes from VSC PR theory. It comes from VSC PR theory. We are having a table in VSC PR theory. Okay. If you say a central element if have 4 sigma bonds and no lone pair, so it is tetrahedral. If central element have 3 sigma bond and 1 lone pair, it means it is which one? Pyramidal. Our task is to find our central element have how many sigma bond, how many pi bond, and how many lone pair. If you get to know about this, then easily you can tell the structure or shape from the VSC PR theory. Okay, got the point? You can tell this about from the VSC PR table very easily. Okay, if you are asking, I'm telling you this is tetrahedral, but this is not our topic for today. Still, we can write this is tetrahedral. What is it? It's pyramid. This is coming from VSC PR theory. Okay, bacha? Okay, next one. I'm taking next one. Right? Okay. Now, fine. Look at this. The next example I'm taking here. Imagine we are having PCl5. We are thinking about the PCl5, right? So P beta, P. Here P have, we know this, it have 5 valence electrons, right? P have 5 valence electrons. Okay. So I am putting the P in center and I am putting Cl. I am putting 5 Cl. You can put Cl anywhere. I'm not discussing the shapes. Okay, I'm just telling how many bonds it will form. Phosphorus have 5 valence electrons. Just tell me chlorine or halogen as surrounding element make how many sigma bonds? Tell me, bache. Chlorine make how many sigma bonds? As a surrounding element, chlorine or halogen make how many sigma or how many bonds? 1 bond. We know it very well, right? So chlorine is making single bond. This also makes single bond. This makes single. This makes single, and this makes single. So these are making single bond, right? Very good, clear. Phosphorus was having 5 valence electrons. Out of 5 valence electrons, all the 5 are used. Yes, beta, good. All the 5 are used in making single bond. No valence electron of phosphorus left. So there is no lone pair because all 5 are used, right? Clear, bacha? Okay. So this is the structure. If you want to ask the structure, I will open the VSC PR theory table. In table, they are writing very clearly. They are saying if central atom have 5 sigma bonds, no lone pair, then structure comes trigonal bipyramid, right? TBP. So I'm writing that it's trigonal bipyramid, right? Okay, bacha? Done? Good. Now the next question I'm asking from you is, think about it, NCl5. The next question is NCl5. This you will tell me. This you will tell me. How many sigma bonds and everything will come? Tell me fast. Tell me what's NCl5. If you look here, just for your help, N, nitrogen have 5 valence electrons, right? Nitrogen have 5 valence electrons. If I put nitrogen here, I am putting the chlorine here, chlorine here, chlorine here, right? I am putting 5 chlorine, right? Now I know halogen as surrounding element make how many bonds? 1 bond, right? Look at this carefully. So making single. It look like same. Rohit saying, sir, 5 bonds are coming. It look like same. Are we doing some mistake in this? Now see carefully. Are we doing some mistake? Are we doing some mistake here? Yes, very good, Gayatri. Nitrogen cannot make 5 bonds. Nitrogen cannot make 5 bonds. Max to max, it can make how many bonds? 4 bonds, right? That's why a very common question they ask, NCl5 exist or not? No, beta. NCl5 तो do not exist. It can't exist. Okay? So this is a wrong thing, right? NCl5 don't even exist. NCl5 don't even exist. Getting my point? Clear? It is wrong because nitrogen can never make 5 bonds. PCl5 exists. P have d orbital. It can make 5 bonds, no issue. N can never make 5 bonds. Fine, bacha? Okay? Good. Remember this. NCl5 don't exist. Next example I am taking here. Very easy. I am talking about SO3. I am talking about SO3. Okay? SO3, bacha. Sulfur have how many valence electrons? Sulfur have how many valence electrons? Yes, bacha, tell me. Sulfur have 6 valence electrons, right? Sulfur have 6 valence electrons. Fine. Okay. If you see here carefully, I will put sulfur as central element. Sulfur is our central element, right? And now here we have, I am putting oxygen here, I am putting oxygen here, I am putting oxygen here, right? Yes, it has 6 valence electrons. Now the next thing is oxygen as surrounding element. Yes, beta. Oxygen as surrounding elements make how many bonds? Tell me. Oxygen as surrounding elements makes how many bonds? Tell me. Normally oxygen make how many bonds? Tell me, please. It makes how many bonds? Tell me, bacha, Gayatri, Rohit. It makes how many bonds? Oxygen make 1 bond normally or 2 bonds? In general, I am asking. In general. Yes, it makes 2 bonds. It makes how many bonds? 2 bonds. Rarely it make 1 bond, but in most cases, how many bonds? 2 bonds. Very good, right? So I am making here 2 bonds. Oxygen formed here how many? 2 bond, double bond here, double bond, and which one? Double bond. Right? Sulfur was having 6 valence electrons, and all 6 valence electrons are used in making bonds. All 6 valence electrons are used in making 6 bonds, so there is nothing left. There is nothing left on sulfur, right? No lone pair left here. Now if you know if central element have 3 sigma bonds, no lone pair, the shape beta, if you see the VSC PR theory, it comes what? Trigonal planar, right? It comes trigonal planar. I'm saying once again, this comes from VSC pair theory, and we are discussing central element make how many bonds and how many lone pairs. That is our main task. Okay. The next thing I'm asking. The next thing is, okay, try this one. Try SO2. Now you will tell me it have how many sigma and pi bonds and how many lone pair of sulfur. Solve by yourself. Here, solve by yourself. SO2. The next question is SO2. Sulfur will have how many sigma bond, how many pi bond, how many lone pair present on sulfur. Okay. This is the question. चलिए बच्चे, here sulfur have what? 6 valence electrons. Sulfur have 6 valence electrons. Okay, Gayatri. Okay, let us check then. Let us see beta. SO2. Sulfur here. I am putting oxygen, right? Oxygen, right? There are 2 oxygen only. Oxygen make how many bonds? Good. Oxygen beta make how many bonds? 2 bonds. So I am making double bond. It also make double bond, right? Out of 6 valence electrons, 4 are used in making 4 bonds. What left? Out of 6, 4 used, so 2 left. Those 2 left will be present as a lone pair, right? So yes, if I count, total bond is 4, right? Total bond is 4, and we know out of double bond always one is sigma, one is pi. In double bond, one is sigma, one is pi. So if they ask by chance, so yes, you will say there are 2 sigma bonds. There are 2 sigma bonds. There are 2 pi bonds. And yes, there is one lone pair on sulfur. There is one lone pair on sulfur, right? Central element I'm talking about. Definitely oxygen also have lone pair, but I don't care. I'm talking about sulfur, central, right? Now, from the VSC PR theory, if you see the table, remember, only sigma bond and lone pair help us to find the shape of molecule, you can say, or I will say structure. Okay, sigma bonds and lone pair, this number will decide the shape or structure, you can say. Okay, pi bonds will not decide. So if you see the shape I'm talking about, especially, or structure, you can say, I covered the lone pair here. It looks like what? Bent, or you can say angular, right? So if you write the shape beta here, I can say bent or angular, you can say, right? Okay. There are 2 different things. What I am saying, listen to me. First, I am saying, in deciding the shape, who is responsible in deciding the shape or structure, you can say, sigma bonds as well as lone pair. In deciding, definitely lone pair as well as sigma bond are responsible. Pi are not responsible. But when I am talking about the shape, what is the shape? In the shape, I will not look at the lone pair. I will look at the bond pair only. And bond pair is looking like it is what? It is a bend shape, right? It is bend shape. Okay, or you can say angular. Done? Okay, bacha? Fine. The next thing, okay, I hope we are clear up to here. Right? The next example I am taking, bacha. And these are the most common example which will be repeated again in your NCERT, in your test all the time. Okay. Some structures we discussed yesterday also. Many important structures. The next I am taking it here. I am taking the SF4. Think about it. Think about the SF4 this time. SF4 I am saying, right? SF4, if you see, sulfur have 6 valence electrons again. We are taking example of sulfur mainly. So SF I am talking about, right? So here I am saying we put the central element and we put the 4 surrounding fluorines. Halogen as surrounding element make how many bonds? 1 bond. As I said, all the time surrounding elements will be halogens or hydrogen or oxygen. That's it. Okay. So we know that halogen as surrounding make how many bonds? Sigma. Single, 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 right? Out of 6, 4 used. So 2 remaining, it will give a lone pair. It give you a lone pair. It give you a lone pair, right, beta? Very good. So yes, if you look at the BSc pair theory, we can see from there that it is seesaw. The shape is seesaw. The shape is seesaw. Very good. Okay. Shape is seesaw, right? The next one, if I say, similarly, if you go beta for SF6, if you go, the same thing will come. It have 6 valence electrons against sulfur. S, I will put here F here, F, right? Okay. So similarly, if we make bonds 1, 2, 3, 4, 5, 6, all valence electrons used in making bonds. That's why I will say when the central element have 6 sigma bonds without any lone pair, whatever it is octahedral. It is octahedral, right? Great. Yes. Okay, good. Now the next thing is, okay, 2 points we should observe here. Look at this one. I'm giving one little new example. Maybe you have not seen this one. I am taking the PCl3F2. This time I am taking the PCl3F2. I have 2 type of surrounding elements. I have chlorine surrounding element as well as which one? Fluorine. So in this case, a new thing we will learn, right? Okay. So in this case, we will see a new thing, right? First of all, phosphorus beta have 5 valence electrons. It's very much clear, very easy to find. I am putting P here. I am putting Cl, 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 and F here. Very easy, nothing tough here. Nothing tough, right? In this case, if you see, bacha, in this case, if you see, chlorine as surrounding make how many bond? 1 bond, 1 bond, 1 bond. Fluorine make how many bond? 1 and 1. This is the structure. Very easy. It is the shape, you can tell me. Very easy to find. It is trigonal bipyramidal. Very easy. It's trigonal bipyramidal, right? Now, if you know about the trigonal bipyramidal, you should know that why we call it TBP. This part looks like a triangle, right? It is a triangle, and this is what? Here, if I connect these, it looks like upper pyramid and one is lower pyramid, right? Now, one question can come to your mind. Okay, before that, look at this. This bond. In this structure, these bonds, if I am saying this bond or this bond I am talking about, this bond is known as equatorial bond. This we call as equatorial bond, right? Which is on the triangle part, which is on triangle like this one, in this plane, right? And the 2 atoms are where? Upside and one is downside, right? This one, this bond we call axial, right? This is axial. This is axial, right? These are axial. Upside, downside, axial. Whereas these are equatorial. Right? Clear, bacha? So now one question come to mind sometimes, sir. Is it possible that I put the fluorine on equatorial and I'll put chlorine on what? Axial. So if there are 2 different type of atoms are available, then you will put more electronegative atom on the axial, right? Out of fluorine and chlorine, bacha, out of fluorine and chlorine, Fluorine is more electronegative, that's why you will keep it where? You will keep it on the axial. Alright, clear bacha? That's why I am keeping the fluorine on axial and chlorine on the what? Equatorial. Fine bache? Yes, Cl on equatorial and fluorine on axial, right? There are some rules, like you can say a Bent's rule, right? So not in NCERT and not that much important for you, but like Bent is there, Drago is there, okay? These are a little bit important, but not in NCERT, so less important, I will say, okay? But still, this point we should know. Clear? Easy? Structure, I was asking structure. The structure is same, trigonal by pyramidal. It's fine, okay, bacha? Okay, I hope we are clear about this. Now, next thing. Imagine I have this structure. I have PCl2F3. I have PCl2F3. Tell me now what will happen. Everything is same only. Still, I have P here. Look beta, I have P and I have 5 locations. Axial and these are equatorial. So first of all, more electronegative atom should come on axial, right? So I will say, okay, fluorine here. Okay, now axial are fulfilled, right? So definitely I have to put third fluorine where? On equatorial. And definitely remaining 2 also on equatorial, right? So more electronegative atom will come where? On the axial, not on equatorial. When there is nothing left, then so I have to keep fluorine on equatorial also, because already axial is occupied by fluorine. Fine, bache. Yes, Gayatri, Rohit, are we clear about this? Are we clear? Fine, good. The next thing, if you see, bacha, I am taking the example of H2O. The next example is H2O. In H2O, which one is the central element? Yes, beta. Definitely oxygen is central element, and oxygen have 6 valence electrons. Try this one, the most important, very, very important, right? And one more thing I will take O3O, so it is also very important. O3, ozone. From here we will learn something, we will learn a point from here in O3 case. Okay, bacha. So if you look at this is the H2O and O is your central element. Hydrogen is what? Surrounding element. You know it very well that, okay, just wait for a second. Right, so here if you see, bacha, yes, if you write here, this is a single bond here, this is single bond here, single bond will come, and out of 6 valence electrons, 2 are used in making bond. How many remaining? 4 are remaining. These 4 beta will be used as 2 lone pair, okay, as 2 lone pair. So you can say it is what? If you look at the shape, what is it? It is, you can say, bent or angular, right? You can say bent or angular. Clear? Now if you go for the O3, now definitely in the O3, if you see, central element also oxygen and surrounding element also oxygen. Central element oxygen and surrounding element also oxygen, right? So in this case, we have some special point in this structure. We have to be careful little bit. Okay? Remember, the element beryllium, boron, carbon, nitrogen, oxygen, these are second period elements, and second period elements can never make more than how many bonds? 4 bonds, right? We have done this point. We have one more point about these elements. These elements can never expand their octet. Means these elements can never have more than 8 valence electrons in their structure. Remember the point. Second period elements will not expand the octet, will not have more than 8 electrons, right? That is also a very important point. Now think about it. First of all, like what we think, up to now we have done many examples, right? And we think this way that sir, oxygen make how many bond? Oxygen can make double bond. Oxygen as surrounding make double bond, right? We have seen already examples. This oxygen also should make double bond, right? And center oxygen was having 6 valence electrons, right? Oxygen was having 6 valence electrons. Oxygen was having 6 valence electrons. So after making 4 bonds, 2 still left, right? 2 still left. So we think what? We think to make a lone pair. So this structure come to our mind first of all. And we can see oxygen can make 4 bonds, not an issue. But now we have to take care about one more thing in our mind, that beta, second pair element or these beryllium, oxygen, carbon, they can't have more than 8 electrons, 8 valence electrons. If you see, now count here, 2 bonds, 4 bonds, 4 bond means 8 electron, and oxygen also have a lone pair. Total how many? 10. That means something is wrong here. Means something is wrong. If we go by our general rule, we come to this structure. If you go by general rule, right? If you go by general rule, this is the structure coming to our mind. Wait for 1 second. I think network issues there. Just 1 second. Okay, is it clear now? Is it network is there? Fine. Okay, so we are discussing about ozone, right? So remember, oxygen can't have more than how many? Can't have more than 8. In this structure, some issues there, right? So I will think it again. What to do about this, right? Remember, after here, when you have made these 2 bonds, octet of oxygen already complete. Because normally oxygen want to make how many beta? Normally oxygen want to make only 2 bonds, right? So I can't make here double bond, because this double bond making will expand the octet of what? Oxygen. So I have one more logic. Okay, I have one more logic here. If it make double bond, so it will have double bond here and 2 lone pair left, right? So we will do one thing. We will use this 2 electrons and I will keep this here as a coordinate bond. I will keep it as a coordinate bond. This is a little new, right? You have to be little careful about this, okay? So you will not make just double bond. You have to make double here and a coordinate bond here. By keeping this, you will see the octet of oxygen still, like, it will follow the octet. It will not expand the octet, right, bacha? Okay, so little good example you can think about it. Clear? I hope you are clear about this point. Yes, everyone? Fine, bacha? Okay. I will talk about the coordinate bond after like 5 minutes. First, let us see some more examples. Then we will discuss how to find there is a coordinate bond or not. Okay. The next thing is, okay, draw this one. If I'm talking about the XeO3, xenon, very important compound. Every time NEET is asking one question from these 18th group element structures, right? XeO3 I'm discussing. Okay, then we will talk about the XeF2 also, and one more I will take here. I will talk about the, you can say, XeOF4, you can say XeOF. Okay. Now, fine, bacha. Look at this. First of all, we are having XeO3. So the xenon have how many valence electrons? 18th group element. So it is having 8 valence electrons. It is having 8 valence electrons, right? Now we'll keep it here. Xenon as your central element, oxygen as our surrounding element. Oxygen as a surrounding element make how many bonds? We know it make how many bonds? 2 bonds, right? It is making 2 bonds. I will make 2 bonds here. 2 bond here. It will make 2 bond here. It will make 2 bond here, right? Okay. So, and xenon have no issue. Xenon is not for second period. It is from down period, can make many bonds. We know it very well, right? So after making 6 bond, xenon still have 2 valence electron left, because xenon have 8 valence electrons. Out of 8, 6 are used. Still 2 are there, right? So these 2, it will use as a lone pair. These 2, it will use as a lone pair, right? Clear, bacha? Okay, fine. So you can see what structure coming? 3 sigma bond, 1 lone pair. As I told, in deciding the shape, sigma bonds and lone pair are helpful. Okay? Pi bond will not decide it, right? So this is which shape? This is pyramidal shape, right? It is pyramidal shape. Other side is pyramid. Clear? The next thing is XeF2 again. Now again, xenon have 8 valence electrons, and I'm keeping it 2 fluorine, right? So please tell me, beta, answer me. Xenon will have how many bonds and how many lone pairs? Tell me. Give me some information about it. Yes, Yogesh, tell me. How many sigma, how many pi, how many lone pair? Tell me. Okay. Shape is fine. Yes, beta. So xenon have 8 valence electron, right? Out of 8 valence, beta, it's making what? Sigma, sigma, because we know that halogen makes single bond as surrounding element, right? So 2 are used in making bond, 6 still are there, right? Xenon still have 6 valence electrons, and these 6 valence electrons will be used as lone pair, right? Remember, when we are talking about the shape, we don't look at the lone pair, we look at the bonds only, right? Look at this. It is what? Linear. It is linear. It's linear, right? It's linear. When we talk about the shape, we don't look at the lone pair. We just see the atoms or bonds. It is linear, right? Clear, bacha? Now, if we talk about the XeO for bache, we are having here Xe, you can say, and O here, and I will say F here, F here, F here, F, right? Now, think about it. Tell me in XeO4, what is the shape? Okay. Just tell me the sigma bond, pi bond, how many? And any lone pair there or not? Fast, fast. Tell me, bacha. What's coming? Okay, Gayatri. Good. But oxygen make how many? Oxygen to make double bond, right? Oxygen make double bond. Okay, great. Fluorine make which one? Single bond. Fluorine make which one? Single bond. Single, single. After making 6 bonds, xenon still have 2 valence electrons, and these 2 valence electrons will be present as a lone pair, right? So if you look at this, 5 sigma bonds, 1 pi bond. Pi will not decide the shape, right? So 5 sigma bond, 1 lone pair. If you look at the table of VSC pair theory, it is square pyramidal. It is square pyramidal. Fine, bacha? Easy? Great, great. Now remember, Okay. Now come to the ions. Sometimes ions they will give, and they will ask you the shape or structure or bond, sigma bond, pi bond, lone pair, right? So remember, neutral oxygen normally make two bonds, 99.9% cases. Sometimes single bond, like ozone I have shown you. It can make what? A single bond, right? When there is a coordinate bond. Whenever a neutral oxygen is making a single bond, definitely it is a coordinate bond, right? But sometime O negative will come, O negative. So O negative will make always single bond, because O negative means it is having 7 valence electrons and it need only 1 electron to complete the octet. Fine. So whenever O negative comes, you will make it single bond. Okay, whenever neutral O is there, you make how many bond? Double bond, right? Means 2 bonds, I will say. Not always double, maybe single here, right? But whenever O negative is there, you make which bond? Single. Okay, I am giving example, one or two example. Imagine a very simple example. I am taking CO3. It is CO3 2 negative. It's carbonate ion. Okay, very common structure in our syllabus. Carbonate ion, right? Think about it. So we know that very well. I will write carbon here. I will write oxygen, and oxygen. And before starting this, just to tell you, carbon belongs to 14th group. It have how many valence electrons? It how many? Sorry, 4 valence electrons, right? Carbon have 4 valence electrons. And there is negative charge. So definitely there is chances that this negative charge is present on which element? Is present on oxygen, because oxygen is more electronegative. Fine. So I will say here this oxygen have minus charge and minus charge. So these two oxygen have which charge? Minus charge. Now try to make the bonds. Okay, this neutral oxygen, if you look at this, if this is the neutral oxygen, this neutral oxygen will make how much bond? Double bond. This will to make double bond, but this O minus will make which bond? Single, double? Single. This will make which bond? Single. Okay, so these will make single bond, right? Neutral O making double bond, but negative charge oxygen makes single bond, right? Okay, this is the structure, very easy. Okay, if you see, yes, structure wise, using the VSC pair theory, I can say it is trigonal planar. It is trigonal planar. Yes, 3 sigma 1 pi, 0 lone pair. Very good, bacha. Great. Gayatri, doing great. Yes, Gayatri. Gayatri, were you in the like Vijayawada in last year? You are doing good, definitely. You are from Kakinada, right? You were in Vijayawada last year? Tell me, bacha. I can remember some Gayatri, maybe you are same or different. Okay, the next example is, I'm taking the example I'm taking NO2 plus. It's NO2 plus, right? Okay, fine, bacha, fine. But you are doing good. It's NO2 plus now. We are having NO2 plus, fine, bacha. So what is there in NO2 plus? Now you have N plus, right? It's nitrogen, it's oxygen, right? It's nitrogen, N plus. This time we have N plus. Be careful, beta. Out of nitrogen and oxygen, nitrogen is less. Yes, beta. Yes, beta. Yes, thank you very much. Now, the next point is, in NO2 plus, bache, if you look at the nitrogen was having 5 valence electrons, but because of plus charge, 1 valence electron gone. So N plus I am talking about, especially I am saying N plus, right? So N plus beta have how many? It have 4 valence electrons, right? So in this way, if you go, so N plus have 4 valence electrons, and now you will see, you know it very well that oxygen make how many bond? Double bond, and which one? Double bond. You can remember, show like this also. N plus is there, so it will make double bond, and nitrogen can make how many bonds? 4 bonds. Okay, so this way you can show, or simply you can show here, this you bracket and plus charge here you can show. Clear bacha, right? Okay, the next thing is same bacha. Here we have Cl. Okay, last 2 example only. Tomorrow we'll see the application of these structures. Okay, how it will help in bond angles and everything. We are having ClO4 minus. Okay, can you try this by yourself? Cl here, beta. Cl here, I'm saying here, is having 7 valence electrons, right? Cl have 7 valence electrons. So try this. O minus is there, so oxygen is carrying how much charge? -1. Okay, so I'm showing you 4 oxygen. And one of the oxygen have which charge? One of the oxygen, yes beta, Afia, yes beta, from where you are? O minus now we have, so O minus will make how many bonds? Single bond, right? Tell me, how many single, how many double bond will come? We are having here O minus, right? So O minus will make what? Single bond. And neutral oxygen will make what beta? Double bond, right? Double here, and what here? Double here. It is what? ClO4 minus. Very easy to say. ClO4 minus. Fine, bacha. Easy to draw. Yes, bacha. Very good. If I talk about the bonds, 4 sigma bond, 3 pi bond here, and definitely no lone pair left. There is no lone pair left. Fine, bacha. Good. Next I am giving here. Look at this. Next one is, if I am giving ClO3 minus, in this tell me how many sigma, how many pi, and how many lone pair on the chlorine atom. We are having ClO3 minus. I tell me bacha fast. Okay bacha, okay Afia. Great. Okay. Tell me now, we are having ClO3 minus. Again, Cl is having how many beta? It is having 7 valence electrons, definitely. So here we have Cl, here we have O, here we have O, here we have O minus. Tell me now how many sigma and how many pi, how many lone pair, and if you can tell the shape also using the VSC pair theory, this will also help you in that. Okay, fast. So if you look at this, O minus, definitely O minus will make sigma, right? Normal oxygen make double. Out of 7, 5 are used beta, 2 remaining. So we'll make a lone pair here. Fine. Okay, great. Done up to here. Yes, Gayatri, right answer. Good the point. Got the point. Okay, now sometime question comes, which of these is there is a coordinate bond present in the given molecule. Sometime question comes, they ask, yes, it is trigonal pyramidal structure. Now the next thing I am asking, sometime you have seen the question, this molecule is having coordinate bond, yes or no? Okay, so for this I am telling you one trick how to find that. Yes, I am writing the shape here. It is trigonal pyramid, or just you can say pyramid also fine. So write a note. You have made the structure and you want to check, is it having a coordinate bond or not? Coordinate bond or dative bond, both are same thing. Remember, first of all, coordinate bond or you can say dative bond. So both are same, nothing difference here. Coordinate or dative bond, right? Now the first thing is here, remember, what is the coordinate bond? Let me tell you first of all. If there are 2 atoms A and B want to make bond, but A have both the electrons but B have nothing, or I will say A and B are making a bond simply, but both the electrons are coming from where? From A only. So A is using both the electrons in making this bond. In normal covalent bond, A also give 1 electron, B also give 1 electron to make the bond. But in the coordinate bond or dative bond, both the electrons will be given by only 1 atom. Clear bacha? Okay, so how we will check that? Maybe by the previous rules I told you, by the rules you made the structure, but when you made the structure you can't tell is there any coordinate bond present or not. That we have to little be careful how to find it, right? The small trick is there. I will discuss this trick tomorrow. There's one thing I'm telling. Normally oxygen make 2 bonds. So whenever oxygen will make 3 bonds, whenever you see any structure, and oxygen making what? 3 bonds. So definitely one bond will be a coordinate bond, right? Okay, bacha. Great, bacha, आप here. Great. So whenever oxygen you see in a compound, in a structure is making 3 bonds, it is always a coordinate bond. Okay, out of 3 bonds, definitely 2 are normal bonds and 1 will be always a coordinate bond. And if we talk about nitrogen, if you see a compound in which nitrogen making how many bonds? 4 bonds. So out of 4 bonds, 3 will be normal bond and definitely 1 will be a coordinate bond. And one more point is there. If in the structure oxygen is making a neutral, oxygen is making a single bond, this will also be a coordinate bond. I will discuss this point in tomorrow class, be taking examples, okay? And in tomorrow class we will discuss about hybridization also, and bond angle and some of the bond parameters which depends on the structure. Okay bacha, fine. Okay, so see you tomorrow. Bye bacha, bye. I hope it is helpful for you. Bye. See you tomorrow.